Hello, friends. I'm Ashish Darbari, founder and CEO of Aximize, and to our new listeners, welcome. To our old ones, welcome back. And today in house, we have somebody quite distinguished. We have the CEO of Mobiveil Incorporated, Ravi Thummarukudy. Hi, Ravi. Did I get your name right?
Ashish, you are perfect. You spelled my last name correctly, so and very few people can actually do it.
Well, it's always a challenge when we are living in a society. We're coming from so many different parts of the world, but I always try, always try. But hey, Ravi, thank you very much for coming in, and I apologize for not being able to schedule a recording with you earlier. Um, Before we talk about the fascinating things that Mobileil is doing now, I would like to start off learning a little bit about you and your past. So tell me a bit about your personal journey. How did you end up at Mobileil and where did you start from?
Yeah, first of all, Ashish, great. Thanks for inviting me for your podcast. Great to be with you. I consider it a great opportunity. Let me talk about my background a little bit. I grew up in a village in Kerala.
Oh, wow.
This is in India, the southern part of India. I don't know if you have been there or not.
Oh, not yet. Yeah, God's own country.
Yes, we call it's one of the most beautiful part of the
Indeed.
world, and we call it the God's own country. So you must visit there. So I grew up there, but when we grew up there, there was no electricity in the village.
I see.
So can you imagine a situation, the difference between the today I'm in Silicon Valley versus I grew up in the village.
Sure.
Now, when you don't have electricity, you have very dark nights. And when you have dark nights, you will see all the stars and planets. And probably the first thing that attracted me was looking at the sky and asking questions. I still remember as a child asking questions to my parents about, all the stars and moon and all the things and why they are there and things like that. And that's probably my first introduction to science and the whole thing about wanting to learn something.
How beautiful. How
Yeah,
beautiful.
and then we did not have electricity when I was in a junior school. That electricity came, and there was a big celebration in the sense that we could see on a daily basis, how they install the electric posts and things like that, and when the electricity came, the electric light, you have the pumps, you have fan, and maybe that had the biggest attraction for me. So I really enjoyed the whole event.
Transformation, yeah.
And I started repairing things like, for example, our radio. I could never see the radio closed anytime. It's always open because
Yeah.
the sound is not perfect, and you might bang on the side a little bit here and there to make it work and things like that. But so I became very much curious about anything electric, and wanted to learn electrical engineering. That was it was set in me at the time.
Sure. So you did electrical engineering in Kerala itself? Did you go to one of these
Yeah, I
engineering?
did. I did electrical engineering in the Kerala University. It's a
Right.
place called Kodamangalam. It's not that far from where I grew up.
Right, right. And then what happened after your electrical engineering? What was your journey from that part of India to US? Tell us a little
Yeah,
bit about
so
that.
so after my graduation, I went to IIT Madras. I did my postgraduate,
Right.
and there I kind of switched from electrical to electronics. So we were studying about electronic circuits and things like that. And as I mentioned to you, my first love was space, and I took up a job as a space scientist at Indian Space Research Organization.
Yeah, ISRO.
Yeah, so ISRO. So I went to Bangalore and I was there for a year or so, and getting involved in the INSAT project. The INSAT was going on, and the International Satellite, that is INSAT. So I was there for some time, and then I thought that I just want to get more into electronics. So I found this group, TCS, They had a VLSI. One of my friends told me that TCS has a VLSI department. So I moved there. I moved to Mumbai and joined TCS. And through TCS, I came out to US.
Okay. But you also were a co-founder of GDA Technologies, if I'm not wrong.
Yeah, that's correct. That happened. So after I moved to US, so I worked at HP for a year, part of TCS, and then I joined Cadence in 1990. I was at Cadence.
I see. Okay.
Yeah. So at the time, Cadence and Gateway, the company that was started by Prabhu Goyal and the creator of Verilog,
Yep.
They just merged, and I joined the group that the Gateway group in Cadence at the time.
Right.
And Prabhu was our general manager at the time. So my priority at Cadence was to promote Verilog to semiconductor companies.
Right.
So that's where my journey into EDA and semiconductor and dealing with the market.
Right. Very interesting. Quite a journey. Very interesting. So tell us about Mobiveil. So when was Mobiveil founded? How old is Mobiveil?
Okay. Yeah. So after I will also mention a little bit about GDA. So
Sure.
After I left, so I worked at Cadence till about 97, so 90 to 97, so 7 years. And at the time, LSI Logic was probably the first one who started talking about IP, and they had something called the coreware technology. So they were building few components that can reuse. And if you remember, before that, it was pure libraries, NAND gates and adders and those kind of levels. But then now we are talking about maybe bigger blocks. And at Cadence, I felt that I could get out and start building bigger blocks. Like at that time, PCI, not PCI Express, just PCI could be one of the blocks. So 97, I left and started GDA to build some of these kind of building blocks. I continued there for about 10 years. We had a quite successful venture at GDA. And GDA was acquired by Larsen & Toubro in FATAC.
Right.
L&T in FATAC.
Right.
And so I was at L&T for a while and then started Mobiveil in 2012.
2012. Okay. So basically, you were in EDA building tools, and then you thought, why don't we build designs and venture into IP? So that was quite, that time IP companies were not that much popular. I'm thinking of late 90s, am I right?
That's correct.
Yeah.
But as you know, one thing that I saw at Cadence was how people transition, or companies transition from own tool to third-party tools. So one of my first job at Cadence was promoting Verilog simulator, third-party Cadence simulator to, let's say, Mitsubishi, Toshiba, NEC, and LSI Logic. Each one of them had their own simulators. And each one of those companies had a CAD group. There are thousands of people developing every kind of software, static timing analysis, place and route tools, and simulation tools, and so on. And what I saw was that the third-party tools become stronger and stronger because they could solve more problems and essentially come down to one thing: sharing R&D. You create once, use many times.
Mm-hmm.
So think about even Intel or IBM or Toshiba those days. They have a huge CAD group. They develop EDA tools just for themselves.
Yeah.
It is a matter of time that the R&D cost is going to catch up.
Correct.
Right?
Correct.
And compared to Cadence, where they could create the tool and they could license to hundreds of companies, and it's a matter of time that R&D cost is going to catch up, and Cadence became much stronger, and the internal CAD group weakened. And for me, the IP is exactly the same way I look at it. You create once, create the IP, then share it with many times. And one of the fundamental things also happened was that along with Verilog, there are many standards emerged.
Correct.
Standards like PCI Express, or Rapid I/O, Ethernet, all became standards. So before that a large company has, let's say, have a chip with an interface with a proprietary. So no one from outside the company will know how to create those blocks.
Correct.
But once the standardization happened, like a PCIe, AGP, and all kinds of different standard DDR, now anyone who can read the spec, create a very good design, spend that effort, make the block, and now we can license to multiple companies. And I truly believe the same EDA paradigm where native or internal tools gave away to the third-party tools. Right. And I saw that in 10 years, how quickly that happened. And I was convinced that if we create good designs, the internal design teams will start using the third-party IP and compared to the internal designs.
So this is actually quite a valid observation, and it's really great to know that you started to think about it way back, even when processor IP had become a mainstream thing, which we now of course we take for granted. So I'm interested in knowing what are the key technology challenges that Mobiveil is overcoming, and what kind of silicon IP and platforms. And I noticed you distinguish between solutions and platforms. So can you explain to us what exactly and how exactly is your, let's say, the wider portfolio of IP structured?
Yes. Actually, I looked at this way. The first question is why Mobiveil, right?
Yeah.
So this is the fundamental question that we need to ask. So the first thing I mentioned to do was sharing R&D, in the sense that you create once and use it many times. This is a good model in general. So that I believe that is one of the reasons why Mobiveil. The second reason is, the customers are struggling to create a chip. To have a successful silicon is one of the hardest things to do on the planet, I must say.
Yeah.
Because it's so complex. So one thing I believe is that I would like to create the design that are proven, that's already tested and in many different ways, so that when you put a piece of design into a chip, that makes the chip chance of success much better. So one thing is to create blocks, standard-based blocks, and test it, verify it, validate it as much as you can, so that a customer take the design and put into the design, this becomes a solid piece of design. And if you look at one of the things we focus is chip-to-chip connectivity. So these are the input output kind of function, like PCI Express, Rapid I/O, DDR.
Yeah.
And if these blocks don't work, the chip is dead on arrival, because this is how you can communicate with the chip. So it is extremely important to have a very solid design.
High speed as well, isn't it?
High speed, extremely high speed. And if you look at the last, we have been involved in this technology for last 20 some years. It has gone 10 times faster, right? It probably went 20 times faster from the first generation, maybe 1 gig to now, PCIe is 32 gig. So that kind of a growth. The second thing I believe when I talk about platform is that just having individual IP blocks is kind of difficult for customers to take it and put it together. Again, now they have to take IP from vendor one, vendor two, and now they have to put together. There are all the challenges of integration, verification, and all that. And we truly believe create as much as we can as a solution. So what we did was we looked at flash storage as a market in Mobiveil and said what all IPs this market needs, and created each one of those components. And we acquired a couple of components. We acquired a company called Proton Digital for error correction, for example. Some of the technology that we have not been dealing with, we acquired that. So we assembled all the IPs and put it together like a chip in an FPGA.
Okay.
We created the FPGA, created the board, created the software, so that our design is a flash storage chip, SSD chip.
Okay.
So we went from not only building the building blocks, but assembling a full chip in an FPGA so that we understood the market. We can have an intelligent conversation with our customer, and the customer can see that it is already verified and proven. Now it is kind of safe to use. It is a risk-free to use. And you know the manufacturing cost of chip these days, right? So anything that gives you confidence, it's something worth gold. So, I believe it's a huge value for a customer.
Sure. So what does Mobiveil mean, by the way? Why does this have a special meaning?
Actually, it doesn't have any special meaning. It is kind of think about what we all thought when we started in 2012, and we believed in the mobile is going to be the world around us. So we are thinking of it's a mobile-oriented world,
right? Which it is.
The code is cut, and sort of.
Yeah. Awesome. So, in terms of your platforms and solutions, would you say you are equally spread between networking, storage, and enterprise?
Our first, the application-oriented solution was into storage. So this is probably a bigger piece. The biggest piece of our business is a storage business. But we have components like Rapid I/O, which is used in high-speed computing, high-performance computing, the data center, wireless networking, and things like that. But we never created a platform there. It was more of a component that is available for the market for us. So the first platform we created was storage. Now we are looking at the next one is for the data center memory and storage. There's a new standard, as you know, CXL. So that is one space that we are investing quite heavily in R&D. And we are going to create a CXL-based memories, CXL-based storage, complete platform for this domain. And the third one we looked at is IoT. And this is why we were interested in the RISC-V story.
Right.
Because we believe that these endpoints requires small, low-power computing engines.
Right.
And RISC-V as an open source is an ideal situation. This has to be low cost, low power, small footprint. So we believe that IoT is the right space. So we started investing into the IoT space. So those are the three things we started creating solutions.
So who are your typical customers? Are you able to talk about it, or is it all confidential?
I see most of our customer engagements are confidential, but I must say that there is no one, most of the semiconductor companies out there, they're all our customers. Almost every major semiconductor company out there license technologies from us. And I look at this way that if we are augmenting the customer's internal design teams.
Sure.
So you can also see that typically the companies that are already well established, they already have a set of IPs, they already have some platforms. So we are not trying to sell the platform to everyone, right?
Sure.
So they already have it. So if somebody's already very good in creating a storage chip, that they probably need a PCI Express or an NVM Express or a piece from us, IP from us. We are okay with that. But when we go to Asia, what you can see is that recently there are quite a bit of investment in semiconductor. And they don't have some of those fundamental platforms and basic technologies out there. So they are the ones who typically come to us for the whole platform. So our engagements in the US is a little bit different from engagement in Asia. We tend to give more integrated, more complete solution in Asia compared to the ones in the US.
Because US has more design houses and they potentially need more IP level integration as opposed to a full platform.
Yeah, that's correct. That's
right.
Yes,
that's
and
right.
Some of the places we are probably ours is the first IP they get, and this is the basic building block of their new chip.
Right.
So they tend to take as much as they can from us. And also, since we are already proven and it's all verified and validated and certified, so it's much easier to start with this platform than they create everything internally.
I am so glad you said the word verified and certified because I was just going to come to that. So,
Okay.
so
Yeah,
I've
sure.
been following the Wilson Research Report recently and picked up that Harry Foster reported that 68% of the IC projects are actually failing in the field first time around, and the same number is running late. And in terms of FPGA, only 17% of those designs are able to be built first time correct. Now, given your business is entirely in not just small IPs, in fact, very big IPs and platforms,
Yes.
how are you making sure that are you in the 68% or are you in the 32%? Which
Yeah,
part of the
we
statistics would you fall in, and how are you able to be successful and guarantee to your customers that your designs are going to meet the requirements of safety critical security standards that are emerging, never mind that they are functionally bug free, which is a bare minimum requirement anyways. So what is the secret sauce at Mobiveil?
Yeah, Ashish, if you notice, I have a lot of gray hairs, been around, and also I have a lot of scars in my back about working on projects and not succeeding. So it's no one can claim that everything is perfect, right?
Sure.
But it is a process, Ashish. About just like anything else, is chip development is another process. There are some basic hygiene factors that you have to follow, and there are no shortcuts.
Mm-hmm.
And like someone said, the trust but verify, right?
Yep,
It's
that's
very
right.
very important. So what happens is from the architecture to the design to the integration to the implementation, there are so much scope for making things worse, and you are not doing it properly, right? It's extremely important that each phase is very very important. And I've noticed, I work with like I said, all the who's who in electronics in terms of semiconductor. I work with customers, I know their design methodology, I know companies who don't write any spec and try to do a chip, right? And I know companies who spend more time writing a spec than writing RTL code. So it's a completely different approach. And what you have to do as a company is to create a successful model. But the fundamental thing is just like building anything, each of the component that goes into that building and each of those component that goes into a chip has to be fully proven and verified so that each building block you are you can trust.
Yeah.
So, in fact, one of my customer.
Yeah, carry on, please. Yeah.
Yeah. So as I was saying that, just like any construction, there's very important. In fact, one of my Japanese customers taught me this. I used to work a lot with Japanese companies, and one of the person's manager told me that we look at the design like a building, and we put a brick and look at from 3 4 different angles before putting the next brick.
Mm-hmm.
This is not like writing fiction and and making changes after changes so many times. So I think that correct by construction is a good way of creating good chips.
So what
And
do
if
you
you
really?
have that kind of process,
Yeah.
that helps.
So you're saying correct by construction, you're saying proven. I'm almost beginning to believe that you are doing a lot of formal verification at Mobiveil. And it looks like your secret sauce has got something to do with formal methods. But feel free to not disclose your secret sauce. But I have a feeling that Mobiveil's secret to success in this highly competitive IP market is this reliance on formal. But correct me if I'm wrong.
Ashish, I think it's just not formal. It is the portfolio of verification that one has to do,
Yeah.
right? Like I said, the basic hygiene about development verification is extremely important. But like I said, pure UVM-based verification, there is no way to catch all the bugs in that one.
And pure formal isn't either going to cut it too. So you need to combine everything. Yeah.
Absolutely.
Yeah.
So in terms of functional coverage, statement coverage, and code coverage, so you have a whole bunch of methodologies, and now assertions, right? So you need to have assertions into the designs. But another important thing is validation.
Yep.
So you go through, logic verification, formal verification, then comes the validation. I am actually a big believer of emulation and validation, right? So what happens is, for those number of cycles to go through to make sure how your design performs, in the end, you have to see it in a FPGA or an emulation box to make sure the software and hardware is working together.
Correct.
And the circuit is performing to the number of cycles that you need. So our methodology is, combining many things, all this included. First of all, start with a good methodology in terms and design methodology, verification, assertions, formal, and validation. And one more thing we do extra is certification. Each one is, most of the technology we work on is a standard. So we go to PCI SIG regularly, take our design, and to interoperate with other PCIe designs out there. We did our NVM Express as soon as we developed. University of New Hampshire, their interoperability lab, we take there and we get it certified. I just saw the email yesterday from CXL Consortium that they are planning to have that. So it's very important for not only the design is good, but we also need to interoperate.
So what does this certification process involve? What is it that you're getting certified? That you are conformant to the standard of?
Yeah, essentially.
Okay,
so standard is a spec, right? Let's say there are thousands of pages of spec, and people could interpret in many different ways. And there is a VIPs, verification IPs available to verify, but even then it's more of an interpretation. Now, once we design, we have to check with other designs. So when we go to a PCIe, essentially you're walking one room to another room and testing with their PCIe design.
I see.
And to see if this works. And USB, for example, is an excellent example, and how easy it became to use that technology, and the logo certification. These are very important in the industry, and especially these are standard based, and now it's all over the world, and it's very, very important to have one common place where the design can be certified and there's a logo there.
Very interesting. So let's do a little deep dive into the cloud and data center market. And let's talk about Mobiveil SIP solutions. What are they? Can you tell us a bit more on that?
Yeah. So last many years, Ashish, we have been focusing on the data center market. And as you know, that is one of the fastest growing space. And almost all the major cloud and enterprise providers, they are building custom silicon these days. And if you also look at who is driving the standards today, it is the data center market. How PCIe is going from Gen 3 to Gen 4, Gen 5, Gen 6, because I think the data centers requires huge amounts of data to be passed to the shortest amount of time.
Correct.
The data crunching has become very important. And the second thing that is happening in the market is acceleration.
Yes.
Right? You may have a special function. So you have the host processor, like you have the Intels of the world sitting as the main processor. But then attached to those devices, you have accelerators.
Hardware accelerators.
You may have a special function. You may have like a compression engine. You may have some special searching function, sorting function. And then some of the programmable devices are being used for this acceleration. Now attaching to the data center chip is also the AI engine, like you have artificial intelligence. You can have lots of algorithms to manipulate the data, search the data. It's very important. So what is happening from our side is PCI Express is one of the fundamental technologies that is in that space.
The backbone, yeah.
So now we are Gen 5, and now Gen 5 is going to Gen 6. So it has been going, I don't know, every 2 years, there's a new generations coming and doubling the speed. So keeping up with the standard itself has become tough, but we have to develop these technologies. We have to go through the process, verify, validation, and so on. And the second most exciting thing that is happening is the CXL, which is a Compute Express Link, which is the coherent connection of the host processor with other engines sitting, other devices sitting in the data center. So this could be an AI chip, and expanding the memory from the host to, typically you have a DIMM module, right? DDR module. So now you can extend your memory to PCIe. Is very exciting. And also, if you look at not only volatile memory, now you are non-volatile memory, like the Intel Optane kind of devices. So it is becoming important.
Right.
Storage is another important thing. So NVM Express is kind of revolutionized the whole storage based on PCIe. So we are seeing tremendous demand for the data center related, could be networking, could be storage, could be acceleration. They are becoming PCIe based and CXL based. So tremendous potential in that space.
What I am actually thinking about just listening to you is that you're building these designs for domains which are going through so much transformation in terms of requirements changing, interfaces changing, and the time to market is not growing either. That's shrinking as well. So you've got to be working very hard and not only making sure that the designs work correctly. They have to conform to the standard version, generation 3 or generation 4, like you said, for PCI Express, and they've all got to be certified before they can be used by your customers with the confidence. And some of this is very hard, like CXL and neural network accelerators. This surely is a non-trivial development effort. What would be your time to market? Are you having a ballpark estimate in your mind right now? Do you think it takes 6 months, or you're talking about a couple of years for your CXL type designs before they, from the first day in R&D to the point that they're actually taped out, fully tested?
Ashish, we have been doing this for now 20 years. So we have a process that we try to leverage what we have. Again, reuse as much as we can. Share the R&D is very important for us. So, for example, the CXL is built on top of 20 years of our PCIe legacy experience, right?
I see.
So we could create this kind of designs in very, very short amount of time. It's more like 6 months than 2 years,
I see.
for example. But that is the first design, right? But then the challenge comes in terms of the verification, validation, certification, and then integrating with the customer chip. And now that chip has to go to production. So now we are talking about 2 years, right? For this whole, our design to a customer production of their SoC is, there is some time involved in that one. But one point that you mentioned is the technologies are moving so fast. The standards are, like I said, the speed is doubling. Standards are created, every 18 months, 24 months. It's very hard to keep up with each and every development.
Correct. Yeah.
And one more important thing, if you notice, that many of this validation we could do with programmable devices, right? But if you look at the standards have arrived, the corresponding devices have not been arrived. Because even for them to keep up with that cadence of migrating from one technology to another and spending literally hundreds of millions of dollars to make the next chip is truly challenging.
And if you bring in the software into the scope and see how fast the software can get developed and cope, and the firmware and all of the whole driver stack, right? Everything has to walk at the same pace, otherwise you're out of sync. I just didn't realize that we've already crossed the half an hour threshold, and I know you're quite busy. I don't want to take too much time, but one thing, Ravi, we do in our podcast is to ask our listeners, based on their experience and personal journey, uh, some tips about building careers for young professionals who are listening to us. Um, what would be your recommendation, especially to the newbies in the field? What are the 5 things that they could do if they were starting a career in VLSI? Um, or VLSI is an overloaded term. I would say they're starting a career in the digital world. Hardware, software, whatever.
Yeah, I think Ashit, as I mentioned, I followed my passion in the sense that I was attracted to electrical engineering, like I said, very early days in my life. And whenever there was a fork about choosing, right, I always chose what my passion. And it's very important for me that I continue learn, and every day I'm excited about learning new things. Every day I'm excited about all the things that are happening in the world around these technologies. That's the first thing. So you don't feel like you're working, right? It's like you're pursuing a passion.
Correct.
So that's very important, and that's probably, I feel, that's the number one item about choosing a path that you are passionate about, you like, and you also mingle with people who are equally passionate about it, right? Even both the companies I was co-founder, GDA and Mobiveil, I'm also along with a bunch of other people who are equally interested in electronics, equally interested in VLSI. That's very important. So you align yourself in a field that you're passionate about, and you also along with a few more people. The second part is choose your path. You don't need to follow any other particular path, right? You could choose. And one thing I chose was, I was very happy. I could have continued in ISRO, which is it's a government organization. It's employment for life type of thing. But I felt that I need more excitement. So I chose to come out and go to the world and see what else is out there. So that's the second thing I did. And you don't need to kind of, at very early in the career, you don't need to kind of get stuck somewhere. The world is open, so you can go out and make things happen. And the third one is, one thing I learned at Cadence is to, in fact, our CEO at the time, Joe Costello, used to say, you think about your customer first. It's a customer-centric approach. So that's the biggest learning that I had from a business standpoint is look at customer, what they want, have conversation with them, and be excited about their own projects, right? So what is our customer want? They want to make successful silicon. They want to make it faster, right? Accelerate their development. And I believe that by providing this kind of value to them and aligning with them, it's very important. So that's another thing that I will say, that always think about your end user and customer, focus on their success, and you will be successful. That's how I look at it. And don't think about your success first and see how it pans out. But I always look at, can I make my customer successful, and through that, can I have a success? And I can tell you, last so many years, I've enjoyed every minute of it, and both companies have been quite successful. And this is part of the reason is looking at that. So for young people, the very important thing I also learned, the fourth thing I can mention is try to provide solutions and not point
fingers.
Solutions.
Yeah.
Try to put together whole solution for customers, because it's so big, complex, that giving piecemeal anything is good. It's a good starting, but it's not enough. So today in this market space, having IP, hardware, firmware, software, how it integrates with the verification IPs, integrated with formals, EDA tools. Try to solve as many things for the customer first yourself. And once you have cooked, put all the things together, and even it could be association with other companies, partnerships. You do this work first, and then make it available to customer. I think this is the best approach, I feel.
No, very, very interesting. So, passion for learning, keeping good company, and exchanging ideas with like minded people, building whole solutions, and
Yes,
customer
yes,
focused.
yes,
These are all necessary things, and I'm pretty sure that our listeners would value these advices, especially a lot of young people who are in their early 20s embarking on a
yes.
career. Hey, Ravi, thank you very much for your time and valuable insights into your history, both personal and professional. And I very much enjoyed learning about all of the different products and solutions you are making and how Mobiveil is carving out a new path for IP integration across the customer base. Thank you very much for your time today.
Thank you, Ashish. It's great to be with you, and I consider it a great opportunity to talk to you.
No, it
Thank
was
you,
lovely,
listeners.
lovely catching with you. Thank you very much.
Okay, thank you.
So, friends, I hope you liked today's podcast. Do let us know by emailing us at info@aximize.com, and don't forget to subscribe to our YouTube channel. Looking forward to getting back to you in a few weeks. Thank you very much.